So Perfect Channel is a startup. We were founded in 2011. We're based in London Bridge. And essentially, we started off as a kind of professional services software house, working with a couple of clients. One of our notable ones is Christie's. They're an auctioneering company, you might have heard of them. And essentially our kind of MO is hey, there we go, is providing kind of trading model based websites for companies. So as I said, we were formed in 2011. So basically, in 2014, we received some investment which allowed us to expand to around 60 odd people. And we decided basically that in order for us to scale and support more clients, it wasn't really appropriate to continue with professional services. So what we did is we took what we learned from doing our bespoke kind of development for clients and put that into a core product which we call Perfect Exchange. And that's what I'm the development manager for. And essentially this core product takes everything that we've learned and we're selling that as a product to clients rather than basically going to clients saying, what do you want, we'll build it for you. Perfect Insight is also another offering we have, which is more of a data science tool. It allows clients that we have to interrogate the data they get from customers using Perfect Exchange and basically do certain things with it. So essentially stuff like this bidder has bid on these things before, maybe they'd be interested in this kind of thing. And what we're here to talk about today is in 2017 and basically where we started maybe towards the end of last year, we realized that we really needed to scale, and the way to do that was to move away from what we had currently, which was an off-site server farm, to moving stuff into the cloud. So next slide. These are some of the clients we work with, and currently right now we're working with Euronext to support them, and we've basically got agreement with them to host all of their production servers in Azure. And obviously to support this, we need to be able to deploy to Azure and be able to deploy quickly. And with our previous kind of infrastructure, there was no way we would have been able to do that. You know, we weren't scalable. It was just not possible. So Dusan is going to talk a little bit about the solution we came up with, which was kind of a bespoke solution, and maybe also talk about some of the challenges and then how we overcame them. And then I'm going to come back a bit later to waffle on a bit more about stuff that hopefully you'll be interested about. Yeah. So Dusan, over to you.
So like you said, what we're here to talk about is the cloud. And our journey into it, or onto it really. As Dewi mentioned, a lot of the stuff that we do is actually client-driven. So this wasn't an internal decision, this was actually client's request, and we made it happen for them. Step one we found in our journey was identifying which cloud to use. Euronext, or at the time we were pushing a Microsoft solution, so we went to Azure. Whether or not that was the right decision, we had to find out. But essentially, our journey became a little bit like this. And if this is something that you're looking at on your drawing boards and thinking which cloud to use and how to use it, probably go back to the drawing board and decide what it is that you really want out of it, because if you end up like that, as a mushroom cloud, which you don't want. It's a lot of work to put stuff back together and then go back to what it is that really your company needs out of the cloud. Because really, this is what everyone wants and has an idea of what they want on the cloud to function or look like. The awesome cloud. And yeah, what we've learned in our journey, we try to apply to the wider product. Perfect Exchange, really, which is our core product. And what we really want to know is how much of our services, or the services that they provide, we use. How much do they cost? what do we offload onto them and make them the worker tier, as opposed to us doing the work that is already being done by someone else. Right, so in our journey, we've chosen a small, but I guess a keyhole example of how we got to the cloud. And this is the why, what, how slide, really. So why we are choosing to talk about this specific example and not the core component is because as part of the DevOps team, we've built an app, really, or a series of apps from the ground up, and it's sitting wholly within the cloud, which has allowed us to take certain liberties and get the most out of it without having to worry about retrofitting things or legacy code or whatever it is that most companies come across when they wrestle with the decision of, okay, I've got this and now I'm moving on to the cloud. So, things like hybrid solutions weren't actually a problem for us. So it's also an interesting case, as it's a non-standard use of a web app. It doesn't use a purely managed code, and it's actually handling quite a large amount of volumes as one of the smaller apps within the rule subsystem that we've created uses. And it's entirely multi-tenanted, which is something that Perfect Exchange wants to become or is on its way to becoming. And handles around, I guess, between 5,000 to 10,000 inserts a minute, which really showcases the cloud's capability at scale and at cost as well, which I'll get into later. So the what it is, it's a simple sort of, well, not simple, but it's highly abstracted and sort of simple to user interface outlook, a web app. It hides and obscures a lot of the complexities behind creating a infrastructure in the cloud through whatever cloud provider you choose to work with. Things like networks, VMs, DNS records, whatever it is all being hidden away behind a few clicks or simple clicks and made to work for us in our specific use case. Taking a step further with Chef, which also configures the hosts in a certain way that we want, and adds a bit of monitoring across all the major components that we need. Create a dashboard, and it allows us also gives a centralized log repository, which really is a precursor to a brain or having a brain within your own set of clouds. But most importantly, it's a migration tool, which is allowing us internally to go from off-site or on-site hosted IoT, UAT, demo, production environments, and slowly moving them away from off-site or stopping supporting off-site and creating everything in the cloud afresh and configured the way we want. So it's aligning the whole process with our company goals, which is to offer the cloud somewhat to our customers as a viable option and allowing us to learn in the process, which we've done a lot of learning already. But just a little bit about how it does this. Actually, it sits in AWS, despite us talking about Azure. We do use Azure as well for all the environments are actually provisioned currently in Azure as a client needs currently has for it, but it can be easily extended into any cloud. Ali Cloud, favorite example, AWS, Rackspace, whatever. For the use of sort of Terraform and these platform agnostic tools, Chef, you can easily pick something up and take it and make it work somewhere else for you. Which is also one of our lessons, which Dewi will get onto. Right, so, well, challenges and solutions. What we've learned, or what we found an interesting subject was, how do we turn command line outputs or tools that we traditionally use just to be used by admins or infrastructure engineers or people that sort of know what they need out of it, do some stuff and run it in an automated fashion or however else they want to, and make it into something that a web application can understand and make useful later on. The answer is a lot of hacking, but actually a lot of it is now, I would say, moot as well. But as with all hacking cases, you do something that you're going to regret later on. In our specific case, for example, Terraform 9 has introduced very cool and solutions almost made for use cases like ours in this instance, where you have remote state file and you can manage it and access it from anywhere, essentially not just from the local host, which is provisioning that environment for you, without getting too much detail into the nitty-gritty. Right, challenge, IPAMs, or IP tables, or subnetting, or whatever you want to call it. Even though clouds are smart, it's still down to you to segment and create the network that you want. You can go about it in whichever way you want. What we've used previously, or still are using actually as part of a legacy solution, it's something like this. I mean, you'll already be familiar with like a dashboard or a table which shows you some network stuff. Great. It's sort of difficult to query. You don't really know what's going on. You have to look for things, and then you open a subnet and find something in there that you think is useful. So that's the old way of doing things. And actually, our provider doesn't even have a queryable interface through RESTful interface, which made it more difficult to use in a sort of automated and programmable process. And also the old way, you'd find that you'd have to go through 4 different people, 3 different providers, and it will take you 2 days to get like a change implemented to a simple request. What we've done was basically created our own solution, which was really the way to go. This isn't ours, by the way, someone else's, but the point is that we have all this data and we can display it and use it any way we want. We actually use DynamoDB for this, which is deployed around a few locations around the world, and it can be queried by anyone and anything should we want to extend the current way of provisioning our services or service or infrastructure into the cloud from anywhere. All right, so the next problem, if it comes up. All right, there you go. The next major factor was actually, as is the case with, I'm not sure how many of you have used Terraform or any sort of cloud provisioning tool, like CloudFormation or anything, is long-running processes. It takes a long time to provision a set of servers or a fleet of resources in a cloud, especially Azure. I mean, so let's save that for later, but it takes between 25 to 35 minutes. Actually, depending on the time of day also. We find Azure is a lot faster in the mornings than it is in the evenings. So maybe Microsoft needs to recycle their apples every now and then, but it's difficult to create a highly available and sort of scaled infrastructure for people to use at your own company or the client side or whatever to do certain things, which is stand up an IoT environment, a demo environment, or maybe even release an update to a production environment or something like that. So we've actually I think Node.js deserves a bit of a special mention in IIS as well. IIS 8 and IIS Node is a very good solution, and I'm not plugging it, but Microsoft does support it. A lot of every other provider does. Not just because it's a cross-platform language, it was actually, which is actually a good thing for us because we can actually move now our orchestration setup to Linux box, for example, which is something that IIS or Node gives us. But Node on its own provides a good way to manage processes, and it's probably a bit of a dev bit in the DevOps bit, but nevertheless, we prefer to share it with you as it's prudent. So it gives us a good way to spawn child processes and forks processes, which can then act or work independently inside an app pool whilst it is responding to web requests within seconds and not actually leaving the browser hanging for 25 minutes until all the resources have provisioned. 1 second, let me just... okay, so let's just click that, we've done that, just process forking. Functional event-driven programming is something that, again, it's made our life a lot easier and enabled us to implement change and new features very quickly. As also part of the whole process, or the whole subsystem is essentially very microserviced and done in a just nouveau way, much different to most like monolith applications that you would find across the .NET world, really, as it sort of leads you down that that path. So yeah, and then implementing callbacks. This is something that really would have really worked otherwise, because all these child processes, you need to know it and manage them somehow and make the master application understand what it is that is happening currently on your process within the cloud. So by implementing callbacks basically everywhere and creating a separate callback interface inside the web app, we now can track, see what's going inside Terraform, inside of Chef, inside the machine booting up, and enable or create an update, an object for that specific environment with its current state, what's going on, full Terraform data set, status, master states, any sort of timelines that you want that can be used for baselines or reports or anything like that. So, right, one sec. Yeah, and I guess finally, the main solution was we found that great, just like any application, it works great on your laptop when you first start tinkering around with it. But eventually, you will have users using it, and they will be more than 2 at the same time, or 3 or 4 or 5. And when you get a whole development team trying to provision an environment at the same time, and it's running on this one box, which uses randomly processes at various times depending on what Terraform is doing at that moment, you realize that you're running out of space and it's throwing errors, which aren't really your fault, but are within your domain to fix. So you can cluster this sort of stuff and load balance it. I mean, in this case, it's a bit more complicated with Terraform 0.8 against specifics, but which is all being fixed in 0.9 for us. But you can still cluster and load balance, not so much stateful processes, but something that requires a specific resource on a specific machine at a specific time. So I guess this is what the cloud is really good for, and allows you to, this is a slide from a nondescript provider, it allows you to do things in response to events. So as opposed to doing that, you don't have to have 20 machines running at the same time to support a development team at night or a client's team at some point. We can just add or take away machines based on their CPU or RAM usage or bandwidth or whatever else it is that we deem necessary at the time to make sure that a specific process finishes completing. Right.
I think it's my turn now.
I think it is, yeah.
Right, so thanks, Dusan. So not too much longer now, I promise. Basically, I'm going to talk a little bit about what our next steps are now as a business. So the first thing is that basically we want to try and take what we've got in the terms of we built a lot of wrappers around a lot of the tools that we're using, and essentially build that into a framework that we can use a lot easier around the business. Because at the moment, obviously, a lot of what we've done has been centralized within the DevOps team. We haven't really got any of my development teams being involved with helping out with this kind of stuff. So having a framework in place will really help make that transition a lot easier. And even the fact that, he's put that up a little bit too quickly, but even the fact that with our code shipping product, which I'm going to talk about a little more in the next slide, it'll be a lot easier to almost make it agnostic of that. So if we want to, we can switch away from that particular one and move to another one. So the next point, machine learning, which Dusan talked a little bit about earlier. We're getting so much data. You did a little bit, yeah.
No, sorry.
We get a lot of data from all of these provisioning things that are happening, which our development teams or my development teams, while they're using this in-house tool we've built. We want to take all of that data and basically almost do something intelligent with it, create a brain process that we can then learn from, and
I would also add that it's a lot easier to do this sort of stuff. Sorry, Dewi, for jumping in.
It's all right. You've jumped in.
Sorry.
Be my guest.
It's a lot easier to do this sort of stuff in the cloud as well. So machine learning is something you can get up off the ground very quickly in Azure, AWS, and I'm sure a lot of the others. And to train it to do this sort of stuff, which is simple data sets of good and bad, which is something they understand and will learn quite quickly, is again why the cloud is so invaluable, and it's cheaper. You don't have to pay people to do this sort of stuff, which is great, but to a simple level like we need it.
That's the thing. I mean, a lot of the cloud is, when you look at it in terms of infrastructure, it's a lot cheaper than going and buying actual servers from a provider like Rackspace, which is obviously why it's so attractive. So the last thing in the next steps is, and I'll talk about this guy in a second, but is that
we have rehearsed this, you know. So.
Is test automation. Like at the moment, we've got a very heavy focus on taking what we had previously, which was just a bunch of Selenium tests running on a nightly scheduled build, and integrating them with our provisioning. So, you know, someone can click the one-click button on our internal tool, spins up an environment, and then it can run these tests we have on this environment, and eventually we scale it to a point where maybe we have 4 or 5 instances of our perfect exchange platform, and then have test drivers running maybe 10,000 tests against each of these things in parallel. So rather than them taking 4 hours, it takes an hour or even less. So
and you can deployments, 10 times a day as opposed to once a month, which is
exactly,
I guess, the main.
So what have we learned from all this stuff? So this guy is an Octopus, obviously. So some of you guys might know about Octopus as a deployment platform. That's what we're currently using. The point of this slide is that basically we ran headlong into using Octopus. We basically just gave everyone access. And any of you that have used Octopus know about the loveliness of variables. And if you give everyone access, they start creating variables and you end up in a hell. So the moral of the story here is plan what you're doing before you use tools. Think about how you're going to use them, and even look at the capabilities they have outside of the out-of-the-box stuff. Do they have any APIs you can interact with that you can customize to maybe apply to your business? Next one. Like Moonpig, we always thought we were primarily a Microsoft house, but more recently, I'd say in the last 2-3 years, we've basically started branching out. And in our production now, as it says there, 70% of our infrastructure is actually non-Microsoft stuff. So we use Couchbase as our document database. We have a few of our bespoke things that use SQL still, but mostly it's Couchbase. And then we use Elastic in tandem with that. We use RabbitMQ as the service bus, and then HA proxy on the kind of infrastructure level. So moral there is don't be afraid of branching out into other tools that aren't within your tech stack, but please make sure that you have someone who knows about that tech stack. You don't get a contractor in who sets it up and then leaves you in the crap. And then the final thing we learned is, as Dusan kind of hinted at, we are using both of these things at the moment, but Azure is our environment hosting, and essentially with managed services that both of these things provide, Azure provides a lot less than Amazon provides. So, but don't be afraid of using managed services. If you host your own SQL infrastructure or your own NoSQL infrastructure, I know that you jumped ahead again. I know that there's a lot of traditional kind of worry from customers that hosting data in the cloud is bad, but obviously that's no longer the case anymore. So use things that Amazon have. They've got things like Elastic as a managed service, so you don't have to host it yourself. They've got Hadoop, they've got Redis, they've got loads of things in comparison to Azure, which has a lot less and also isn't as performant. So our recommendation is go with AWS and don't do what we did. And then finally, with monitoring tools as well, as I've already mentioned, a lot of our stack is non-Microsoft now, so we have a lot of Linux boxes in production, and we weren't prepared to basically be able to analyze the performance on these things, because as most of you know, if you come from Microsoft and move to Linux, it's very difficult to actually know what the hell is going on with these machines. You don't have Task Manager, you don't have any of this stuff, so make sure you're prepared to have monitoring tools, and this was something custom we built after the fact using Grafana.
But also took very little time, provided a lot of the stuff was done for us. You could use things like Lambda as well, stateless servers, which we haven't actually discussed, but it would be ideal for this kind of thing. But anyway, sorry, Alan.
That's all right. And I promise this is the last. Well, it's the last but one slide. So
that was it. No.
Key things from us that basically we hope you take away is that with DevOps, obviously, we went the route of to try and speed things up. We split our DevOps team up. We gave them all the responsibility to build all these tools and investigate all these things. Now we need to share that knowledge within the rest of the business. We can't just keep it within that team, because if those people leave or something else happens, maybe they all get killed somehow in some accident.
The bus number is pretty low.
Then we're going to be screwed. So we need to share the knowledge of these tools throughout the business. And I'm going to say something cheesy here, but obviously DevOps is 2 words put together, development and operations. We need to make sure that that is the case, that both these teams work together. So what they've learned needs to come to my team, so we need to help them out to move this thing forward. And like Alec Baldwin said, always be closing. Let's try and see how we can apply this cloud stuff to the rest of the business. So our example is with sales. We are enabling them to quickly provision pre-sales environments, which they can then use to demo to clients, without having to wait like 4 or 5 days for a development team to provision these things. So we're already seeing the benefits of this thing. And finally, cloud is obviously a buzzword, maybe still somehow. Try and make it tangible, make it something that people understand and know throughout the business, so that they can provide ideas and ways to move it forward and to improve your implementation. And that's it.